my God. Now that the 4-rotor short block is ready for assembly, Isaiah put up a roadblock. He said you gotta do all these other things before you are allowed to assemble that engine, because you know as soon as that engine's in, I will see nothing but billet 4-rotor. This is the next thing we're working on. This is the front cover for the front diff, and it has been wonderful. It was built by Sano and then modified by us over the time, but first of all, it's steel, which makes sense, it's pretty solid. We can move the diff backwards. With the diff moved backwards, we gain better steering radius. Like we can turn the wheels tighter because the front axles aren't binding up and hitting things. It's really a beautiful thing. So not only that, we can move it up as well. So that way, as the wheels are articulating up and down, it's more centered. And another thing about CV joints, the joints on my axles, the more straight they are, the better that they transmit torque safely or reliably. I made a nice little program, but what we're gonna do is test the limits of the CNC machine right now. This massive chunk of aluminum is the largest piece of metal we have put into here. So this is truly my first billet. Like when I say billet, we're talking about something that'll break your face if you throw it to your friend. Like this is a massive chunk of aluminum, and there is a replacement this hidden inside. I know that machining content doesn't always do like mainstream, but this is the 4-rotor and this is very important to me. That said, I am going to send this machine as hard as I can. I'm pushing the limits and we'll see if it throws something, but we got the GoPro in there and we are going to cut as big of chips as much as possible. What this is the back side of the diff cover. So it's actually, we'll basically have like a really cool bowl of this all done. It'll hold a little bit more fluid, but also make room for the ring gear that spins right here. Here we go.
What?
It aired out, and I know why. Because the chunk of metal is so wide, this is starting to push the limits of the machine, I actually have to tell it to cut into the metal sooner because the tool can't go all the way over here. So we're just gonna go in. We're cutting at 0.4 inches, so it's going. That's what I'm doing right now too. I'm actually gonna slow down the feed rate for the first couple seconds because there's just no way to guarantee this. In perspective, that spindle is 30 horsepower, so we're using probably well over 20 horsepower to cut that much metal. That was violent. These are actually chunks of metal, they're not even shavings. They should be about 7 or 8 thousandths thick, so look at, they're not even bending well. That actually, look at that, it actually left a beautiful surface finish. It's pretty cool. That took a total of 1 minute and 33 seconds. Wow, the block is hot. Like it's just like slightly.
Dude, I can smell it.
Yeah, it was starting to cook. That is impressive. The machine just keeps getting crazier and crazier. And we have a lake. Look at this. And we have so many chips that it can't clear them. But let's look at what we've just done. What do we have here? If you guys are early 80s babies, you'll recognize this as the original Ghostbusters logo, the real Ghostbusters. Crazy. That roughed out that pocket. We'll go ahead and send in a curved piece to make this even looking prettier. We'll just let it go, but that was impressively fast. Man, that smooth finish, even, look at that, it's almost mirror finish even though we were doing a rough-in phase. You can see my fingernail. Those chips are, look at this. Those are some beefy chips. They're like Frito-Lay. There are faster ways to do this. I don't know them. You actually can buy this like auger, like ice cream auger thing, slushy machine thing, and it'll pull all the chips to this corner and dump them out of the way. But the machine backs up because look at down here. There's these vents, and in those vents drain the coolant underneath them. They fill up even with metal. Those are cool ass chips. We go pretty hard around here. This is not a traditional type of shop. And with that, I need to make sure that when that door is open like that, I need to know that I am safe. It really is an issue that unfortunately has come to light, and fortunately, I am SimpliSafe. SimpliSafe has done a phenomenal job at keeping my peace of mind. Everything gets monitored. This is my temperature sensor. All the way up in this back corner, I have motion sensing, a smoke detector. We have cameras and of course the base station. I have front and back door entry sensors. And actually, that's kind of funny is that I've had these for almost 4 years now. And I'm gonna show you how simple it is to add one because I destroyed one. This is one of my favorite things about it, because I know if somebody's coming in through the front or back doors of the shop, pull the pin on the grenade, right? Boom. So we'll log in on my phone. Just simply go to settings, device settings. What I'm gonna do is just add a new entry sensor. And you press this little button on the side here. Entry sensor. It took more time to film setting it up.
That was really quick.
That was way quicker than I thought it was going to be. Save 20% on your SimpliSafe system, and your first month is free when you sign up for interactive monitoring. Go to simplisafe.com/RobDahm to sign up. That's simplisafe.com/Rob. Guys, this is the sort of thing that we're getting good at. Look at this three-dimensional stuff. Very, very pretty. This is what the ring gear will see with oil splashing all up on this, so this doesn't need to be too amazing, but at least you know that it's beautiful on the inside. Just like me. And the outside, it's just beautiful. That is such a cool pattern.
It is. Oh my god. I need to know if you can do it. I'm gonna end up destroying this machine. Oh my god. That is not right.
There it is. That was technically a finishing pass. It's my first attempt at making something this beautiful. My god, did that turn out amazing. This just smooth and it looks and it feels exactly as smooth as it looks. Nice clean edges all around here. The wild trippy, you can't feel that either. Just all of this turned out utterly amazing. And that thing just shines in just about every light. That was 8 in the morning when that all finished up. It's all my cell phone footage because I was just all by myself. Joel's back and we can take a look at how insane this is. First of all, those are very, very thick chips. I filled the whole machine twice and had to take them all out. So it was about a ½ inch off of this, and we took all that material down in 12 minutes flat. I accidentally went too tall and it started cutting in up here. So the squealing in here was actually the tool hitting up here and still cutting metal on. It's not supposed to do that. This thing's definitely a monster. It's rough, and I pushed the machine. I had been told by a couple people that worked with Haas or from Haas that they're like, yeah, you can push the machine past 100%. And so you tell me that, I gotta try it. I can't just trust. I believe you, but I gotta verify it. And this machine went up to 180% capacity. It was nasty. You could actually smell the motor. So we'll not do that again. We did it once, but look at the end result. This took a total on this side of the 12 minutes plus an hour and about 5 minutes, an hour to do this pattern. And my God, did it turn out perfect. If you're wondering, I did not machine in the fill or the wheel speed sensor. Those are things that I didn't overlook, but I was just kind of in a rush to make the base plate. I also have to machine the 3 holes and tap those holes so that way this can mount in here. The way that this is gonna work now is that the steering rack is still right here, but we'll build a plate out from the stock chassis so this can just sit on there and then bolt in. Before, we actually had to unbolt it and it was underneath the steering rack, and you couldn't do that without getting the steering rack out of the way, so you'd ruin all your alignment. Now it's got a kind of a secondary plate, and so you can just set the diff in first, let it sit there, and then bolt it in. Very, very happy with that. This path is the exact shape of the differential gear, and it is exactly a 1/2 inch thicker than this. So this entire piece is a 1/2 inch thick. It's 70-75 aluminum, so it really is a stronger aluminum. Let's see how much it weighs, and then let's see how it fits on the diff. For comparison, here's what we used to have. It's a steel, I think 4130 chromoly steel plate. This is 0.3 inches thick, 0.35. So it's thinner than this, but it's steel. Let's see what sort of weight we're talking. So it's about 6.5, whatever, pounds, what? I don't know what a pound is. 16 ounces, so almost 7 pounds for a much smaller piece. Let's go ahead and put this one on there. Whoa. And yeah, we shaved, what, 2 pounds exactly off of that, and it's much thicker. It's got more fluid capacity, and we're gonna be machining the bolt holes and stuff out of it, so we'll actually lose a little bit more weight. So I was gonna machine like tool paths and cool stuff into this, but I didn't have time. I wanted to get this done. Let's test it on the diff. So we'll spin the diff the correct way. So this, we're looking as if we're the front of the car right now. Just set it. Okay, that's a really good sign. It's got room to let that ring gear not hit. So the ring gear doesn't hit until way over here. Now here's the moment of truth. Put all these bolts in. Funny enough, I don't know who put this all together the first time, but they used 3/8 inch bolts, and that's about the closest bolt. This is a M10. It's the closest bolt from a metric to US where you can confuse the two for about 5 threads, 5 full threads. You can't tell the difference if you're new to it, and I don't know how that got past our guys, but these are just threading and fine. So these are M10 1.5s, which is what BMW would naturally have had. That's what threw me off. I scanned this in the CNC machine, and so look at this. These holes are exactly 10 millimeters, and they all are just on point. We got these two because I wanted this piece to be as wide as possible, so the flange on these isn't as wide. Look at all these are just threading in. You see all the bolts are up like that. There's no dowels or anything like that. And nothing's moving. We have a solid front diff. It's surfaced. We'll probably surface the steel on this part. That is beautiful, and you can kind of see like the shape is, I designed this with the center of the ring gear in mind, so it really does fit the aesthetics, and it's, I think, going to be much stronger because of how tight these bolt holes are. We're also using the correct hardware. I'm going to go ahead and machine in a fill and a speed sensor, so that way we can tell the wheel speed between the front and rear wheels. We shaved some weight, and oh my God, does it look good. All those bolts line up perfectly, and even these are still, it's not wedged, except on that one. It's not wedged at all. It is a cold and rainy day here in Southern California, but that doesn't stop the progress. As you guys know, earlier in the video, we went from this to this. Massive difference, massive improvement in stability, strength, flatness, and the lightness of this. The issue we're going to have is making sure that this now lines up properly inside the chassis. We not only gained all those other benefits, but this can now sit properly in line with the axles at ride height. So vertically, it's in the correct position, and front to back, it's in the right position. So that way the axle is close to zero when the car is at zero, and when you start to turn or start to hit a bump, that's when the axles articulate. Instead of already being flipped up like this, and then when you try to turn, the axle's already on an angle. We have not yet drilled these holes because we have not yet made the intermediate plate from this to the tube. That's our primary mounting position right down there. What will happen is the diff will move further back up a little bit. Both those things would make you think that it's gonna hit the engine, but I designed it not to be. And then we're gonna repurpose this area right here again to be able to hold that diff in place more, because it does twist. It causes the drive shaft to hit the runners of the exhaust. So we've got a little bit of torsion going on there. By a little bit, I mean a lot. That's the point of the car, right? It's supposed to be launching hard, and of course, that diff under load is gonna twist. We may ultimately make something, again, we did long ago, we had a bar that was holding over here too. You can actually see the remnants of that bar right there. But we may recreate that or something like that, just to really make a nice diff cradle to hold it in place.
But the only actual thing I could trust on this car, since it's not symmetrical, is the suspension points. And then this bar happens to be level with the car or close enough. So every time I do anything, I have to make sure I'm going off of suspension, or if I'm going across the car, that bar. So right now, we have 2 different slabs of concrete. So if I'm trying to get it perfectly level, it's actually going to be like pretty much impossible. But so with that said, ride height is where the control arms are even with the car, so they're straight across the car. If they're any down or any up, that's not ride height, or what it's supposed to be. So that's the constant in this car. So with my little degree finder, I go to the middle of this, and it's 0.8 degrees up, right? Come over here. I'm at, what does it say, 0.8 degrees up. So that's perfectly fine. And the only reason why I'm able to do that, and Rob confused me, he's like, how is it sitting like that? And I was like, the A-arms are tight and it just sits. He's like, no, but how is it sitting like that? I don't know what you mean. But I had to take off the cantilever, so that way, the cantilever actually pushes it down with the shock and whatnot. So this side is even with the car. This side is even with the car. So now to that, I have to somehow get these hubs, the center of these, in line with that guy over there across, and I have this hole that I can pretty much put in. It'll actually go across the car pretty straight.
Yeah, it's crazy. It's crazy.
So based off of that, this should be 0.082. Yep. That's at 0.9. So now, based off of this, I have to get the center of the diff in line pretty much with this pole. That way when it's at ride height, which technically the suspension is at ride height right now, the axles are straight. They're not up, they're not down, they're straight. Based off of Rob's dimensions, what he said in CAD and everything, I have to move it 0.75 inches, so 3/4 inches forward, and then 0.75 inches from the back of the pumpkin. So I guess technically the front of the pumpkin up. I don't have a lot of room because we already hit the header, so I'm gonna have to rotate the nose of the diff down so that way it clears the header, and I gotta raise the back of the diff up so that way it's even with what it does. That's gonna be tough. We're actually gonna have to countersink these nuts. Got them. I guess I countersink these because the mounting bolts, we're not exactly sure. So he left this blank right here. We're gonna have to figure that out. But fortunately, that's not a big deal. But the only thing that's weird is now we have to make an adapter from the 2 bolt holes that we have on the actual chassis right now to this, or have to make a bracket that mounts straight to this. I'm most likely going to make a bracket because I don't want to make an intermediate bracket. So I'm probably going to hit in a weld into the car. I'm going to take these off so that way it's easier to get to there. You're going to be seeing that out when he makes me these bolts, but let me tighten this up. This thing looks bitchin', dude.
Yeah, it's badass.
Really nice. Actually, since I know that from where this diff sat before, I need to go 3/4 inch forward. I marked right here, so since this has to stay the same height, if not lower, to get this drive shaft to be straight and not hit the header, I'm just going to drill out this hole so that way I can put the diff into there. Then I could bring the rear of the diff up and down as I please. Alright, so I drilled that hole 3/4 inch forward, which is how far we need to go. And I have the jack underneath to support the little ass end. In there.
Like I try to
Put that thing in there. That's funny, you're going exactly with the music.
Yeah. This is the other half of the equation when it comes to making this 4-rotor turn like the Unicorn. This is my stubbier side of the front carbon fiber axles. So this is on the passenger side, and you can already see the problem, or at least you can see the result of the problem. Shredding this boot tells you almost everything you need to know about my issues with this. I am trying to turn this car very tight, and when I do, goes inside the tire, it starts making this clunk, 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 because it has to rotate around those balls inside of that CV joint. So you can see it actuating inside there. And it was hitting the heads of these more so than anything else. As it was turning really tight, trying to copy Ken doing the real quick 180 at the end of the runway, it was that's the problem here. So my solution, coincidentally, is actually copying off the Unicorn again. I didn't know that he uses these parts, but Drive Shaft Shop makes these, the D6184, and this allows some very cool things to happen. Let me show you from your point of view. Imagine this is in basically the center of the tire. We'll look at it from the top point of view. When the tire turns, the center of this pivot is way out here. So that means if it was even longer, that'd be swinging way out like this, and it would cause this kinking. So the dream is to have it closer to the center of the tire, so when the tire turns, this isn't moving as much. So this gives us almost an additional 2 inches closer to the center of the tire of turning. While that one swings way out like this one will do this, and it can turn much tighter, just because it's closer to the center of the wheel. That's the biggest difference, much less it should actually shed some weight, because this is a big CV joint, this is a little cup for it, this is both of those together. This is semi-permanent though. We're going to have to install a compression ring onto the end of this carbon fiber axle. What we're going to do first is see what this spline and everything looks like after even just a little bit of racing. You can tell why I'm wearing all this shit is because this is very gross. And these are all worn down slightly because of hitting. Well, turning was such an intoxicating feeling though, doing that. This ring should pop off, which means this CV joint should separate from here now. Nice. Okay, so you can already see the CV joint doesn't even start right there. It's past that. So the fulcrum, or whatever you want to call it, is right there. We're going to get it right in there. CV joint actually looks fine. Nothing crazy there. Let me show you guys. No weirdness there. This really hasn't ran long enough. But what I'm looking for on this back side, hidden inside of all of here, is that. Ooh, that compression ring was already half off.
Whoa.
That's not good. Compression ring should have 2 little things right there, little nipple things, that we're gonna extract this one out. It's really wild. I really think, and I do think that people see it the same way, the drivetrain for this car is probably the most unique and most insane parts of the car, because it's making all custom parts. None of these go together at all. And in this case, even these axles are probably one of the most beautiful unsung heroes. They're sick, but they're the unsung heroes of the car, because you have to do all these wild snap rings and order of operations to make sure that this diff and this wheel never explode. Things don't fall apart, but they can move, but you have to do them in the right order, but you have to lock it in this way, and yet hold half of 1,000 horsepower, 500 horsepower plus per wheel, plus all the torque. It is a very, very tall order. So like hiding that snap ring in there means that it won't pop out of this CV joint, but we can't get behind this one. So that poses a problem. To get this to service this thing, you actually pop it out like that. Well, if the axle's in there, you can't pop it out. What we're going to do, instead of this snap ring, we have to do a compression ring, so that way when we push it in there, it locks in almost forever. Interesting enough that that's starting to pop off, so there we're going to go into both of those. That's a snap ring, and you can see the concept is that you snap it down onto this. We can't use a snap ring, and I'll show you why. With a little bit of suggestion, should pop off of this. There we are. Oh, I see why it didn't. That's a very shallow ring right there. We had an easy time popping off of that. What it looks like we are going to do, hopefully, step 1 is we take these new shorter handy dandy guys, and they fit. They better be the same spline. Okay. I wish we could just be done there. Oh, we should be able to see that this should be able to show us the tighter turning radius of this wheel. While Isaiah makes this center more centered to the wheel at drive height, this allows us some serious angle. Look at that. Let's take that boot off to really get the idea of how crazy this is. So yeah, let's see this turning radius in action. Car's at center and we go to turn. We'll pretend the car doesn't hit a bump, just to keep the example simple. So the tire can really turn.
Oh.
Yeah, I'll turn it up to you. That's the turning radius in theory. What happens is if you hit a bump, you've now added more angle, and the tire cannot turn as tight. So look at it from your guys' point of view. Ignore it three-dimensionally. Just look at it two-dimensionally. That is the highest angle from this line to this line. If I was to hit a bump, a huge bump, we'll just say like this big of a bump, still looking at it from your point of view, this is not as high of an angle. It's not sticking up as high because part of the angle has now gone to the bump. So your turning radius would, in theory, shrink. This is at ride height. That's an angle. Now, we had the problem that the diff was at the wrong angle right at the center. At ride height, it was already like this. We lost out on tons of angle to begin with. That is a lot of angle. And the bolt heads aren't even in the way, which is even better because on the other one, the bolt heads are right there. Look at that. That is amazing. We gained so many degrees of turning.
Looks so cool.
Doesn't it? So much to this. And again, with the diff, just so you guys see, with the diff moving in more centered, this won't move as far. And it won't hit that little arm right there, so we won't fuck up our carbon. And then on top of that, this thing is no longer swinging. Like, remember, let's pretend the diff stays still, which it does. When the tire turns, this whole thing isn't swinging as far as the other one. The other one would be like, woof, woof. This one is turning way less, moving the axle. Just so much benefit to this. One of the negatives to this is the total length of the axle from end to end has now shrunk because we're using a different piece. It's shrunk about an inch, inch and a half, I'd say, and we can measure it 100% accurately. The good news is when I measured these, I overestimated them because I didn't want them to be too short, and so we were on the longer side to the point where we actually had to kick the wheels out a little bit more just to accommodate for this. So shrinking it in a little bit actually helps us because, see this on this side? Mm-hmm. That's a plunging CV joint. So this joint is meant to go in and out, whereas the outer one is only meant to turn. You don't have as high of an angle. Look at that angle is shit, right? Compared to the outer one. What you lose in angle, you gain in adjustability. We had these all the way shoved in because the axles were too long. Now they'll sit in the center, making this CV joint even more strong because it's centered, and we get the right length of an axle. All win, 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 win. So this is super exciting now that I know way more about this, that we will now strengthen our axles. Sad to say, this piece was, I want to say like 700 bucks. It's like 300M, whatever type of heat-treated steel, and I had to have it machined custom for this. This CV joint was a couple $100. You know, it's a high angle RCV, something or another. All that's for nothing. Rob, why can't we reuse this ring? Well, this style ring is designed to go on this after the other thing has already gotten in there, snap ring. A compression ring, on the other hand, is meant to go into this thread, basically almost hide itself until you push the other thing onto it and then it locks in. So if we were to put this on here, especially with these little areas here, you can't push that on. It won't go in. So what I'd have to do is it'll either be like an actual like a piece of wire. There's snap rings that are just literally that thin, or snap rings that'll be little rings, actual like piston rings. I'm gonna have to lathe or machine these threads, that hole, deeper, so that way the thickness of this can go down inside of those valleys. So the valley has to be cut down to the thickness of this, so that way the ring completely disappears when all the teeth of this get pushed through here.
Pushed it 3/4 of an inch forward, and so now I'm just trying to get it level with this. So that obviously that's more than 3/4 of an inch up.
Yeah, we'll bring it back down.
Okay.
Only because of our U-joint right there.
You want me to bring it down to a level that you think is okay? I'm going to put the drive shaft in, and then we'll go down to whatever we think is okay from there.
Obviously, remember, originally, I was freaking out about a fraction of a percent of a degree.
Did we ever tell them that story?
Yeah.
We did?
Yeah, it's in the video, yeah.
Yeah.
Yeah, when our guys from the drive shaft company came out, and I was stressing about the drive shafts, because for long-term use, what I was saying was right, is that you want, there's harmonics with your drive shafts, not the axles, the drive shafts. You want minimal angles, and like you want like the two pieces coming in like this, so the angle is the same, and you want your U-joints at opposites, so that, anyway, there's all these weird things. And then one of the guys comes in here, and we're stressing out.
Rob was like, dude, there needs to be like 0. He's like, maybe 1 degree or something. Like, dude, there's no way.
Yeah.
And this guy comes in, we kind of like, dude, this is with our hard limitation. We can't do it. He's like, oh, I've seen worse.
Yeah, it was such a non-issue.
Yeah,
it's such a non-issue.
I looked at Rob, I was like, you really had me stressing out.
Yeah. So the issue here is that we are now going to put more stress on the front CV joint or U joint currently, and we want those as centered as possible. Now they aren't centered because right now the front drive shaft is in 2 pieces, and so they do split right there.
To get that completely level,
yeah,
it needs to go up, like I said, like another 1/8 inch, because it's like 1.7. It's like maybe a degree to half a degree off, and that the middle part needs to go up.
We'll drop it back down. I mean, this is beautiful for...
Drop it down to wherever you think it is, and I'll tell you what the angle is over here. 0.41, 81.7.
That's in the realm of...
And okay, so if that's the case, let's see. We do that. That is close. Let's see. We're at 3.7 degrees.
Okay, so we lose 3 degrees, basically. That's how subtle it is. We don't want to fuck over our core power to both wheels, so we lose 3 degrees sitting at neutral. That's kind of the whole point of that, is that what I was talking about over there is that if we're at 0, 0, 0, we gain 100% benefit there. So we would lose 3 degrees, but we don't put that U-joint under a really bad angle and snap it under launching. Somewhere in here makes me feel safer. Well, we'll probably have to modify the cantilevers, because now we're getting closer to the center of the cantilever. Closest distance between the center to center and the tip of the cantilever.
Yeah, I see.
Definitely work that over. That's not an issue. Unfortunately, the moment where we would get the worst angle is at full bump. So the car hits a big bump or turns really hard. The tire is not going to want to turn as tight in, which is sad, because that's like, you want the tire to turn in as hard as possible on a bump. The dream position is if this was slightly higher, so that way when you hit a full turn, the tire can do whatever it wants.
There's no special drive shaft thing that makes give you more angle.
The only thing we could do is switch to CV joint, but that's huge. The U joints don't like angles. If we make this a bad angle, the front wheels will they'll surge. And
It's better than what it was right now before.
It's way better. And because we had the diff forward, we also were losing angle, because when we turn, one side would always bottom out.
I think the easiest thing to do is to weld those spacers and a bigger plate underneath, and then just have them straight into like a bracket. So if I put like a plate, like a super thick plate in that corner, put those long spacers on it, the ones that are in there right now pretty much, but actually they have thicker ones, or a tube, and that way the bolt could go through it, it's strong, and then it bolts into your cover.
Probably put a plate on the top of the spacers.
We could do that too, yeah.
Yeah, just to give as much surface area to surface area. Yeah, that works. That works to me. You've got a good channel for the bolt heads, but I like the idea of, like you're saying, the actually being longer bolts, so the bolts are all the way down at the bottom.
3 3/4 to the bottom of the tube.
That's not bad.
And I could pretty much make that all outside of it. You want to do 2 bolts or 3 bolts?
I thought about doing 3.
Okay, we can do 3.
Just because it's aluminum.
So between 4 inches, you have 1, 2, 3 spaced out apart.
Yeah, I was thinking at least like M10, M12, or ½ inch, whatever, equivalent. Like, all of our big stuff, all these are all US.
Okay.
So
then we'll just keep our suspensions are the US. I guess we'll just keep it US.
yeah. I just can't stand it. She does it every night, and she just ruins it for me. The damn cat opens that door, rhinoceros style, and ruins the room temperature every time. Whether it's the summer, the winter, as you guys know, I stay here. Hopefully my landlords don't know that, but during the week I do. And that cat, boom, every time. She,
I like that.
yeah, that's what she does to the whole door. And I'm telling you, I even put shoes, like hey, a rubber stop behind the door to prevent her from opening it wider than she can go. And she's like, no, and knocks the door open like a foot or so. And so, it either dumps hot air into there or cold air into there. And it's about time that we introduce her to this, some $15 doohickey thing. I get some options. The most socially awkward is that I can lock it to let her out of the room and then keep it locked and then watch her stare at me going, how have you done this to me? How have you, like, that I kind of enjoy that option. Of course, you can do the other option where she can go either way, right? But my favorite is this one, where you just get screwed. You can't. You're either gonna be in or out. I really don't care. I just want her to be able to go in and out. But the biggest problem is I'm not fat shaming her. We just sized it up next to her. And, she's gonna use 100% of this.
Tight fit.
Yeah. So she's gonna learn whether or not she can eat or go to the bathroom, if she can fit in this or not. So we're gonna go ahead and just cut up the shop door and fit her ass through this. It's not what I should be doing. That looks good. What do you guys think?
I think a little bit lower for her climbing.
Okay.
You know, she's gonna be a little groggy in the middle of the night.
Yeah.
I don't want her to step too hard.
Yeah, that's true. Maybe a little bit lower.
Yeah, I think that's decent.
Yeah. I have a feeling we're gonna end up having to replace this
Door.
They're not gonna be like, hey, that was cool. This is gonna be the easiest material ever to cut through too. We're gonna go fast now.
Maybe. Yeah. Yeah.
That is
A little crooked.
a little crooked.
Okay. It's okay. She's not gonna know.
Let's see how the shape turned out on the other side. You okay?
It's for you.
That is horrible. Look what it did to
Whoa.
this. Damn it. Look what it did to this side of the door. Okay. So I learned that. Hell, just leaving that hole would solve 90% of my problems. You'd never know that this was done to the door. You're gonna teach an outdoor cat to use a cat door.
No, not terrible.
No, it really, for the 5 seconds of work.
Now to train her.
Yeah. Good luck. I think that she's gonna have to be taught how to use the door. And we're not trying to scare her or anything like that, but we want to see if she can fit. We need to know now. So you guys are gonna stay on the outside. I'm gonna suggest her to go through the inside.
Yeah, you're ready. Yeah. Okay. Oh, she was perfect.
This is a good baby. That was awesome.
She used to have one of those, huh?
Yeah, that was awesome. That answers that. She was like, no. She actually genuinely fits it perfectly fine. I think I pushed the lid up a little bit myself, and she got it. What I'm about to do sounds very crazy, and that's because it is very crazy. You give me better tools, I still end up doing some hood rat shit. So we are going to use this beautiful little device, since I do not have a lathe, and I don't have a lathe even close to my proximity to solving the problem I have here. So what we're gonna do is use these little notch things that I bought for E-shaft reasons and completely misuse them. And I'm gonna actually set this one kind of in a spot and then hold it there. And you can already see a hint of one of my tests. That little ring right there already, that was a test of making my own, we'll call them snap rings. Compression ring isn't exactly correct because that's implying compression. But you know that what I mean by compression is that you have to compress them to remove them. But then technically they're still called snap rings or retaining rings. But we're going to simply be able to hold this into a position and then rotate this very carefully to cut the depth I want to cut. It is far from accurate, but it's much better than I need to do, and it'll accomplish what I need to do, which is seat this ring inside of there. I'm gonna show you guys how I made this ring and make it very repeatable, so that way both sides of the car get the same exact ring. I'm really happy with how this turned out, actually. It's a welding rod, but it's stainless steel welding rod, so it's pretty strong. It's not like tool steel, but it's still very, very strong. And it fits, look at that, it fits right in between the teeth. The only thing that's stopping me from using it right now is we haven't cut the depth of this. So this disc is slightly more narrow than the compression ring, or the snap ring. I'm gonna have to do a little bit of unfortunate work back and forth. Thankfully, neither of those are as wide as the existing groove. So still proof that I need a lathe, but I have not gotten one. That process was a little bit more hands-on and not accurate than I thought. Realistically, I still need a lathe. We could chuck the lathe. If this could go through the lathe would hold on to it right here. It'd be very centered, and then we would just all the way in. That said, I did it a little bit more manually, and I was able to get just the right height so these things sink where the top of the spring is just underneath the splines. I literally went to each tooth and made sure I just went and worked it over. It's just right there, you can hear it clip. And so it'll be a tight fit, but that's the point, is that it might take a little bit of work to push them together, but then the spring will release and hold it right together between all the splines. The downside to this is I forgot to get a new boot for this. We'll see if JE Reel or CarTech or any of the other guys locally have those tomorrow. Then we can install it. Once it's going on, it's not going anywhere else. So it's definitely not going anywhere. The downside to setting the 4-rotor aside for so long is that I forgot I ordered certain parts when I did order the CV joint to begin with. Now, this boot, I don't know if it'll work exactly for what we want, but we will find out. And without the compression ring on, we'll make sure that everything fits up still. Teeth are clean. Okay, yeah, so thankfully we're still good there. What I'm worried about is when this thing's at a wild angle, make sure this boot actually doesn't become a pain in the ass. My work there actually looks pretty clean, better than what I've done in the past, but this little boot would go on up to somewhere like right there. And then we'll slide this back on, so pretending we have the ring on, which we don't. So the question for me, can this move fully without shredding this part of this ring? What I'm seeing happen is that this stuff is in the way between this metal and this edge of this metal. So if I turn it too tight, in this case, see that? It's gonna hit this metal to this metal, and it's gonna cut this entire thing, which will in fact happen. This boot's gonna eat it too. While we're working on this one, it gave me the opportunity to compare what will be to what was, and the results are insane. So right here you see the one that we're working on right now. It is not fully connected, but it is ready to go. And I wanna show you guys from the camera view, so I'm gonna be only articulating it perpendicular to you guys. So it's articulating this way for the camera. You can see that we have, it's like a 45.7 degree angle. So that is, I'll set it up on the counter like this. With the camera low like that, you can see that angle as well. We will set that out of the way for a second to compare that to what we have. And so we'll pull back the boot just to show you again, same problem on this side is that the bolt heads were rounding over and they were touching along here. You can actually see the indents right there. Very thankful that the bolt heads are all rounded over on the entire sides of them, meaning that the bolts spun because this can only hit the inside. Thankful that it mostly tightened them. Looking at it again from the camera's point of view, and with the bolt head being the limiting factor, that is the greatest angle of articulation. We will take this, hold it right like that, set it on the counter like this, and we'll actually put we'll put this little box right here underneath the end of this, so you can see from top down just the angles. Now I already know the angle differences, but we'll compare these two basically equivalent to each other, and you'll be able to see if they're the same angle, these two would be in parallel. So this angle and this angle, it ends up being an extra about 10 to 15 degrees more, almost 15 degrees more. So this is a 31 degree angle, and this is 45, if not slightly more. Utterly insane. If we do it this way, maybe it'll be more obvious.
Yeah, match the angle of the...
Yeah. So you can see from the top, this one really steers much, much more. And I'm even pushing this one past where it should be. It'll hit the bolt right there, and it actually, if we go, there's the bolt head again. It does not turn as tight as even right now. That is just simply swapping from this combination to this setup. We gain so much more visually right there. Downside to it is, of course, like I said, is it's slightly shorter, and we have to worry about how far in this travel here. My goal is to have it sitting right in that middle with the diff in the correct place. Both of these do the same thing, but in reality, they will be in or out slightly. But we want them centered because that's the strongest point of the CV. So we're gonna go ahead and deal with our boot situation, which is really funny. This is one of the two original boots that did survive, and it is useful, but it had the same problem that we're facing right now, which is this causes the boot to go in here, pinch, and then get cut to pieces. Our solution to that is not to do the same thing and get the same results, because this one does that right there. I think we're gonna cut this ring off so we gain this ring, and then we're gonna use a larger boot in here. We picked these up from CarTech. Imagine that that ring goes between the two of these. Let's get this fitted together like that. And so we're hoping that it lets us kick that boot out a little bit more. So when it bunches up, it's hitting metal on metal, which is what we want. So it'll put the boot under some serious strain. We're gonna have to wire these down really hard. This is gonna be a very interesting situation because 2 sets of rubber is gonna make them want to fall off, but they're gonna sit somewhere here. And as long as they don't collapse and pinch, this will be a serviceable, ongoing usage situation. So same thing with this one. We're gonna remove this whole piece now that we've compared the two, and we'll get it all cut up just like that one. There we go, another successful separation. So even this boot, sadly, is trash. I didn't see that until I went to move this. Wow. So yeah, we're about time for this one to start shredding too. That is honestly half of the problem done, and I'm really happy with how that turned out, but the other half is equally as very precise, or at least has to be way more precise than even this. I'm very happy with how I did this. It was very feeler and minimum cuts needed, but how do you make the right size retention ring? Well, I ended up taking some stainless steel welding wire, which is this here. This is 050 or 040, it's somewhere in there. It's gonna work perfectly because it fits the entire length of the teeth, so the valleys and all that. The issue is we have to make sure that this ring fits completely around the whole thing, not too big and definitely not too small, or the retention aspect of it does not work. What I did was I wrapped the wire around multiple different things of different diameters until I got the exact size that I wanted wrapping around it. So check this out. So stealing this from Isaiah, and follow me. Different sockets make for great, different weird ass diameters. So you got a lot of different choices in your own shop, and you sometimes don't even know it. So I'm simply going to pinch this between these two. Not too hard. And then first round we're just gonna throw out. We don't even care about this round right there. But then trying to keep consistent pressure on it. You see all those Instagram discovery stories that people ripping off other people's videos, but they show them like making springs and stuff like that. And this is a very manual way of doing what they do in real life. So just keep kind of that same level of tension. For the hell of it, we'll just go a couple more. My goal is a consistent diameter. I don't want it to be off. So we're gonna go ahead and let go and see what happens. And so look at that. The first one and the last one are all messed up, but the inner ones are almost like dead on. What we will do is cut off the ones that we are not going to use. This end, and then for sure, we'll just go with the first whole ring. So this looks pretty tasty, modified as we need, but I'm gonna give a cut to about right here, and although it might not need to be that far, my compression ring can now go smaller when it compresses. So do the same thing on this one. And there are actual formulas to all of this, but this is still going to work for what we need. Now I'm going to simply rotate it the other way, and there we go. Make sure those tips aren't weird, and we'll verify that these are the correct diameter. Maybe shrink them a little bit, stretch them a little bit, but make sure that they sit in the center of all those teeth. So we'll check that out now. See how it looks right there? That's a little too small because that is not engaging the teeth. It's going to shrink into the hole. This is basically the compression ring compressed. So we're going to take that and just from end to end, just bring it open a little bit. So it kind of tries to open evenly. And we want it basically, you see this lip right there? We want it to basically sit right out there when it's relaxed. If it doesn't sit there, we need to make sure it does. So we're almost right in that place. The groove is just deep enough to hold just the ring. Like it can't go deeper into there. And the ring is the right size, that way when it comes back out, it's gonna prevent teeth from slipping in and out. I'm pretty happy with this. I remade the second one, that's why I had extra material, so it was closer together. Now, this might actually be too close. It has to press down when it gets assembled, so we do have a case where this could actually be too much material. We'll put it on there, and you'll see it'll want to touch. Now, the nice part is that channel is actually a little bit wider than this, so I think we might be able to get away with this. But with that ring being held in, I'm really happy with where that's going to sit. This is still all prototyping stuff, but once we really get all this stuff figured out, you won't be seeing this sort of level of experimentation. But this is, in a nutshell, something that'll work really well. And now we're going to cut the lip off of this one before we get any further. So I'm going to try and make this easy in preventing myself from hurting myself. So we're going to just cut roughly in here. This is probably the thing that I think will fail first, is this double lip thing. The guys at CarTech, which are really awesome guys and very knowledgeable guys, say it'll work, and they do it for all off-road stuff. That's a really beefy ring right there. Oh yeah, we're gonna have to cut even that ring off. The angle I'm dealing with is right inside of there. So what I'm gonna do, very gently, go down until I hit that ring. Right there. Okay, so that means we have to at least cut the right there.
Pretty much most of it?
Pretty much most of it. Oh yeah, this is much safer. So we'll cut past it. Kind of hoping that this gives me the rigidity, keeping as much material. These scissors are beastly too.
10 kit?
Yeah. That doesn't look like much of anything left. It's like a G-string.
Speak from experience?
How it feels to wear? Yeah. So yeah, we're clear of that angle. And then we're gonna have to fit one of these boots on top.
Wow.
Hey, that actually does feel pretty comforting. We'll assemble this one right now. Might as well. We have to grease. Cracking open one of these can suggest only one thing. No, I didn't run out of the previous one, we lost it. Because this thing is gonna outlive me. Ooh. Hello. Joel asked off camera, real good question, is that do you use like red grease or whatever can you use it for just about anything? Because it says all around general stuff. The answer is no. Red grease is all around, meaning it doesn't have a specific purpose. I'm sure your bearings work for a little bit, but not under these high stress circumstances. First thing is we cleaned off all of these rings here, but what I wanted to do was get the grease inside of these spots. At the risk of getting a couple cotton fibers in there, I wanted to bend it, get it in these tracks, and we're gonna pack it full of grease, but this is just me being me. As long as I see these tracks getting grease, I know that I did my best. It's time to assemble. Make sure this is grease free here. Make sure everything that is gonna be held together is grease free. Everything that is not being held together is greased. There's my ring. So we're gonna slip the big boot on first because this is gonna get grease. So we slip the big boot on. Now it's just in the way of everything, right? But we need to grease the splines here in front of them first. We'll put our retainer ring on. Actually, the grease can continue holding that too. So now I want to pack this with grease. Grease is basically like oil, except it's meant to stay in place. It's thick because it's got a job to do. Good, bad, or indifferent, I'm going to take a couple chunks of it and put it in the middle because there's kind of a bowl in the bottom of it. And in my mind, again, I think of the grease as kind of like a heat dispersion as well as lubricant. Inside of there is the back side of all these. There's no real downside to putting grease in there. We'll get it right to where this starts touching this lip right here. That's where the boot would be sitting normally. We'll just simply install this and hope the snap ring works. Okay, so we've now gotten to the snap ring. So we're, whatever, a quarter of an inch onto this thing. I have a feeling that this will be somewhat difficult. And I hope so, because that means the snap ring's doing its job. See, I can't get it over the snap ring. So I can't compress the snap ring easily.
You want a tool of suggestion?
A plastic tool of suggestion. Okay, let's hope. Yeah, that's a good sign. That's a really good sign. That's my snap ring. I'm very proud of that. And I made that out of thinner material, so if shit hits the fan, we can remove it.
How do you do that?
This is my power stroke. He thinks that's the first time I've done that. We'll put the metal band on before we start bending it because it's gonna put pressure on this. Look at this, Isaiah. That's my snap ring.
Nice.
Joel and the guys from CarTech got us a little something to finish this job properly. This band has to be really tight, almost to the point of breaking it off. This is apparently a tool setup for tightening these metal bands. So just watch CarTech's website because they actually show you how to use it. So I had it upside down, I was close, but there's a bend that has to go into this. So we'll get this upside down like that. We'll get this tool in here too. So we'll just start getting some tension on this. And then before we go any further, we'll make sure it's nice and even across the whole thing. So we only really get one shot at this. And we are going to go a little bit harder than they're suggesting because of the double booting scenario, because we need to capture this lip that's actually running kind of this side of the boot. That's cool. It's got the little ratchet stop right here. Okay, so now we're going to start fucking up the boot if we go any tighter. I guess we can test it, right? Hell yeah. That's a good sign. That was metal on metal. What they do now is they just simply bend this over, keeping this tight. And then they use the cutter right here. And then a baby hammer to give it some love. And so, you can see I've got the tension still on there. If it's gonna snap off now, we better make it. Better learn. So you can see it flexes that little bit. That is our maximum with my snap ring. Okay. What you'll notice is right about there is where the boot does bind up, but I use that word carefully because it'll still go down to here. But you see where the boot is kind of resting right there. So we'll try to prevent this thing from going all the way to there. I'll try. I will try. Being able to turn really tight is pretty sick. That's still a hell of a lot of angle left. That's way far beyond what it used to be. And then with all the stuff Isaiah's doing with the diff, I doubt we will push it this far. I think the tire will actually hit inside the wheel well and actually hit the upper control arms long before we get to this level. We'll have to shave them even more. When I go to remake them, they'll be even sexier. This is no longer going to be our limit at all. Put this ring on. Okay, so put this on first. I think I got the retention ring on. I got everything cleaned out. This is cleaned out. I got the second band on here. Got the big one on here. I think we're ready. So we're back at that same spot where my, oh yes, retention ring. There we go. This one, I knew this one was gonna be a little easier. That tool makes this so easy. Like it's not even close to difficult now. We'd be like screwing it up without it. Because you're just trying to pull it with pliers and it's bending. It's not.
This is like a metal zip tie, basically, right?
Yeah. Pretty close to how much tension the previous one had on it. Do the flip. Hit it with the cut. That is 2 for 2. Oh my God, I'm so thankful this process went this way. So this one's gonna be turning way more because it's a smaller one. And there's a nice safe zone and then there's that a little bit further. There we go. There are our remodeled, ready to kick ass axles for both the front turning wheels that gained us up to about 15 degrees of turning. So after all of that work on the axles, why not test them, right? And this is where I am so happy to see the results. So this is the baby stub is all the way inside the hub. Being a bub. I'm not really good at rhyming on the spot. And so you can see this is our Prince Charming right there. The diff is gonna sit now almost in line. The diff used to sit closer to here, and you see my first problem is it hits this and that. So the diff is gonna sit a little bit further back so that this is more in line, and it's gonna sit up a little bit higher. So at ride height, where this lower control arm is, right now, we gained about 3 degrees of angle. Now, we're gonna go ahead and turn the car to the left. And you're gonna see that the car actually hits this cup right here, one of our things from preventing the Dahm joints from falling out, shit like that. It actually physically hits that first, and the diff can still go even farther forward, which it will not. We gain all of that steering angle. If we put the tire on this, that angle is gonna cause us to hit this upper control arm on a rebound. I think on the bottom bump, it hits the lower control arm, but you gain all of this angle. Now, again, we have another issue is that we're getting so good at this that we're gonna have to clearance and figure out how to do my cantilevers a little bit better. They hit right there. Imagine that they're not gonna hit, and you see that the angle that it's gonna hit this right here as well. And we're not at the limit of the CV joint anymore. So we got all-wheel drive, and we've got way more angle than a stock FD has, way more angle than we ever had. That is so much better.
The diff is in place. It is at the 8 degrees that we have turned to bring it up. It is at 3/4 inch forward, so that way it is in line. This side right half is even, the axle is in there. So this is at 82 degrees, which makes this an 8-degree tilt. So not too much, but it is still kind of a lot. This guy is at 6 degrees. That is where she sits right now.
That's pretty good. Just for reference, this spring is no longer being held back by the lower control arm, so this is in a different spot than it should be. It actually sits way higher and interferes less with the axles. But what I'm mostly concerned about right now is actually making sure the diff side to side is in the right spot, because unfortunately I see a lot of space inside of here. That is at the absolute limit of the inner joint, and so as soon as the wheel moves up and down, it'll pull that out. Well, our dream goal is to have this sitting like right here, so as the car bounces up and down and turns around, that can travel. But let's get the other one in as well and see if the diff plays nice with both of them. So here's the issue I was absolutely terrified of, and it showed its ugly face a little too much. That and this really stretch both sides, both axles. That cup's not even in all the way, and it's not in all the way over here. So if I pull this one to there, they're both extended beyond their supposed to be operational limits. Well, it is unfortunate that my axles are slightly short and I'm gonna have to undo the work I just did. It was absolutely critical. It's completely necessary to be able to make these sort of measurements and see just where to put the diff, because we know that it is now centered between both these axles. We can get axles that are slightly over ½ inch longer and get those remade in a reasonable amount of time. It doesn't change the diff situation. We can get that finally mounted with a beautiful billet front cover. Isaiah just added the fill. This is like OEM status. It is amazing. And so we're gonna also take a look at the measurements between this front drive shaft just to make sure that that's within its range. But the angles are so much better. You can see it with everything all in together. You just see that the axle is no longer the limitation. That hit is this down here, and it's gonna hit the tire here. Like, I'll be redesigning these because these are the very first thing I did. All of this is gonna hit first. When I get to redesign these, we'll gain even more angle, but that's not the point. The point is that the drive shafts are along for the ride, and they are looking great.